Okay, number 1, triangle A prime, B prime, C prime is the image of A, B, C after a dilation. Find the center of dilation, there we go, and the scale factor. So to find the center of dilation, you're going to take each of the points and connect them. So if I connect the A's together, I connect the B's together, and I connect the C's together. Oh, that's a little off. Where they cross, oh, did I mess up? There we go. Ah, sorry. C prime. Let me fix my B line. That one's all messed up. B. There we go. That's a little better. Okay, so where those 3 lines meet is the center of dilation. So that would be at 3, 2. To find the scale factor, you're going to do new over old. Okay, so I want to take one of the sides. Let's go from C to B, and I want to count down here as though I was doing the slope. So I could do 1, 2, 3, 4. So that's the old because of there's no prime. This one's the new. So from C to B, I have to count down 2. So new over old equals 1/2, and that is the scale factor. Number 2, draw the image of ABCD under a 90 degrees clockwise rotation. Okay, so clockwise you go to the right. So I'm going to rotate, and then I'm going to write these points. So from here, as though you were looking at it normal, find this coordinate point. Well, I have to go right 1, 2, 3, and down 1. So 3, -1. Do the same for B. Right 1, 2, 3, 4, down 1, 2, 3. So 4, -3. Do the same for C, right 2, down 1, 2, 3, 4. And the same for D, right 1 and down 2. So now when I rotate it back, I want to draw those points. So to find the new A, I'm going to go right 3 and down 1. That's A prime. To find the new B, right 4, down 1, 2, 3. Oops, 1, 2, 3. C is 2, -4. And D is 1, -2. And there's the new shape. Number 3, name the object that exhibits rotational symmetry. So that means what object can you rotate and it's going to be exactly the same. A car, definitely not. Butterfly, no. Triangular sandwich is if you have your, see if I can draw a sandwich bread here, and then you do your triangles. It's not really perfect. It's not an equilateral triangle. So let's go with the circular plate. Number 4, graph the figure reflected over x equals 1. So the line x equals 1 is going to pass through the x-axis. So right here. So we need to count the points. So this point right here is 1, 2, 3, 4 to get to that line. So I'm going to go for the other direction. 1, 2, 3, 4. Do the same thing. So this is 1, 2, 3. So I'm going to go 1, 2, 3. Draw the point. And the bottom one, 1, 2, 3, 4. 1, 2, 3, 4. So there's your reflection over x equals 1. Number 5, RST has those vertices, and it says if it's reflected over the x-axis and it moves 2 units down, what will the coordinates of S prime be? So let's take S. Let's take S and go over the x-axis first. This is the x down here. So 1, 2, 3. So I need to go 1, 2, 3. So that would be like S prime. Then it moves down 2. So from there, I'm going to move down 2, and that will be the newest point. So that is at -2, -5. Okay, number 6, rotate the rectangle 180 degrees counterclockwise about point T. So if you take a rectangle, let's just look at an example. If I draw a rectangle like this, and I was to rotate it 90, I'll put a point here so we can visually see it. 90 would be like that, and then 180 would be like this. So it's almost like it's the same triangle, but then the point is up here. So let's see if we have one like that. Or sorry, rectangle. I said triangle. So we could look at this one right here. If we rotate it, we'll rotate it around this point right here. So I'll put my pencil on that point. There's 90 and there's 180. That would be a horizontal, so that's not it. If I do this one, rotate it 90 and then 180. If I rotate it 90, it would be like this, and 180 would be then on the other side. This one, 90 would be vertical, 180 would then be horizontal. So I believe it is J. This one's really hard to tell because there's nothing to really visualize with. But if you take this rectangle and you turn it 90, see if I can show you, it would be vertical. And then if you take it another one like that, it's in that same kind of quadrant if you were to split it. Number 7, which generalization best describes the pattern shown in the figures below? So how do you get from this one to this one and this one to this one? So it looks like if you look at one of the dots, so this dot is rotated down this way to get here, and then it goes to the right, to the left, and then back again. So it's rotating counterclockwise 90 degrees. Number 8, graph the reflection of the shape over y equals 2.5. So y equals 2.5, here's 2.5. So we want to over this line right here. So count your points. So this one's up 1.5. So I'm going to go a half and then 1, graph the new point. This one right here, down 1, 2.5. So I'm going to go a half, 1, 2, graph my new point. This one is just a half, so go a half above that and graph your new point. And there's your reflection. Number 9, write the coordinates of the image of P negative 2, 5 reflected in the line y equals negative x. So negative 2, 5 would be right here. So if you're going over y equals negative x, that means you switch x and y and change the signs. Okay, so if I switch x and y from negative 2 to 5, it would become 5, negative 2, and then I change the signs. Negative 5, positive 2. So negative 5, positive 2 is P prime. So if you look at it the other way, y equals negative x is like this. So you could count the diagonals here. It's like 1.5. So you go a half and then 1. You could do that as well. It's flipping over this line. The easier thing is this, switch x and y and change the signs. So negative 5, positive 2. Number 10, which could be used to create a regular tessellation? That will be all of these. So we created one from a square, but we could have done it from an equilateral triangle or a regular hexagon. Number 11, what type of dilation occurs with a scale factor of 2/5? So this is less than 1, so this would be a reduction. If it's bigger than 1, it would be an enlargement. Number 12, determine the scale factor for each dilation. Determine whether it's an enlargement, reduction, or congruent transformation. So let's start with scale factor is new over old. So let's start with the new one, and we'll just pick a side. 1, 2, 3, 4, 5, 6, 7, 8. So 8 on top. And let's go to the old one. We have 1, 2, 2 on bottom. So 8 over 2 reduces to 4. So we have two options with 4. And since 4 is bigger than 1, then it's an enlargement. Number 13, find y. So let's set up a proportion here. Let's do this middle side, 2 1/4 over y equals 6 over 16. So if we cross multiply or bat and ball, we get 6y equals 36. So I did these two and I divide by 6, y equals 6. Number 14, simplify completely. So when you're dividing radicals, we want to multiply the top and the bottom by that radical to to get rid of the radical. We're rationalizing the denominator. So multiply across the top, 8 root 2 over, when you multiply these two together, you get square root 4, which is just 2. If we simplify the 8 and the 2, we get 4 square root 2. Number 15, I'm going to do a factor tree. So 2 and 25, 5 and 5. There's a pair of 5s, and the 2 has to stay inside the square root. Find the distance between 2, 6 and 5, 3. So we could do distance formula. On a graph, you could use Pythagorean theorem, but it's hard to kind of look at that. So let's do distance formula here. So we do x1 minus x2. So 2 minus 5 squared plus 6 minus 3 squared. So that would be negative 3 squared is 9 plus 3 squared is 9. 9 plus 9 is 18. So then we need to simplify the square root of 18, which I'll do over here. So 3 times 6, 2 times 3. We have a pair of 3's, so the 3 is on the outside and the 2 is on the inside. Number 17, which set of measures could represent the sides of a right triangle? So which set will fit inside a squared plus b squared equals c squared? So you can test some of those. So I'm going to do this first one. 2 squared plus 3 squared is 13. 4 squared is 16, so that doesn't work. B, 7 squared plus 11 squared, is that equal to 14 squared? No. C, 8 squared plus 10 squared, is that equal to 12 squared? No. 9 squared plus 12 squared, is that equal to 15 squared? Yes. Okay, so I'm checking this. I put that in my calculator, which gave me 225, and I put 15 squared in my calculator, which also gave me 225. So those match. Okay, number 18, we want to find the altitude, so you can use geometric mean here. 4 over x equals x over 16. X squared equals 4 times 16 is 64. So I'm cross multiplying here, or bat and ball. Square root, x equals 8. 64 is a perfect square, so you just get 8. Number 19, find x. So if this is an equilateral triangle, and when we split this, this is now 10. So we have a 30, 60, 90 triangle. And in a 30, 60, 90, if I want to find the long leg, that's equal to the short times the square root of 3. So I want the long leg. I know the short is 10 times the square root of 3. So I'll just leave it like that. Number 20, find x to the nearest tenth. So from the angle, look at what side you have. We have the opposite and we have the hypotenuse. So our trig function we can use is sine. So sine 67 equals x over 20. If I want to solve for x, I'm going to multiply by 20 on both sides. So in my calculator, I'm going to put 20 sine 67. And I get 18.4. So x is 18.4. 21, now we want to find the angle. So we do the same thing though. From the angle, what sides do you have? You have the adjacent and the hypotenuse. That trig function is cosine, so we say cosine x equals 6 over 10. If I want to get rid of cosine, I have to do cosine inverse to both sides. So that crosses out the cosine there. And then in my calculator, now I'm going to do second cosine of 6 divided by 10. And I get 53.13 for the angle. Okay, 22, find x and y. So you could, this is a 30, 60, 90 triangle, so you can use your special right triangle information, or you can use your trig identities, or trig functions, whichever one you prefer. So I'm going to use trig, because it's a little bit easier. So from the 60, I have opposite, and I have hypotenuse, which is sine. So I'm going to say sine 60 equals y over 24. And in order to solve for y, I'm going to multiply by 24. So in my calculator, I put 24 times sine 60, which gives me 20.78 for y. Okay, so now my answer choices here, I've got 24, well that can't be it. And I've got 12, that can't be it. So let's plug in these and see which one of these answer choices is the same. If I put in 24 square root 13, that's 86.5. Oh, sorry, it was a 3. 24 square root 3, that's 41.56. And if I put in 12 square root 3, that gives me 20.78, which is what we got. Okay, but let's do x just to make sure. So then if I'm doing x, from 60, I have adjacent and hypotenuse. So I can use cosine this time. Cosine 60 equals x over 24. Multiply by 24. So in my calculator, I'm going to put 24 cosine 60, and I get 12, which is what we found on J.